Hi everyone, this is Kuljit Singh Gariwal. I'm working as postdoctoral associate at School of Architecture, Planning and Landscaping at University of Calgary. So I'm presenting this research in PLIA 2020 under the supervision of Caroline Heckham-Vermeete. So our paper is titled as Energy Sharing Between Sustainable Residential and Conventional Commercial Building Cluster. So coming to the overview of this study, the objective of the study is the estimation of energy sharing potential between upgraded multi-story residential building and conventional commercial buildings. This case study is performed in Calgary, Alberta. So the average lowest and highest temperatures are minus 31 degrees Celsius and 36 degrees Celsius respectively, and the peak solar intensity in the Calgary is 1200 watt per meter square. So coming to the definition of clusters, so we are studying a mixed-use cluster that has residential and commercial buildings. Residential has two multi-story buildings with the total floor area of 7,040 meter square. So each of these buildings has BIPV installed at the roof. So we are also considering three types of commercial buildings known as office, retail, and supermarket. So we are actually calculating dependent area ratio to be electrified by MSR BIPV. Next is the assumption. Assumptions of this study include MSR buildings are assumed to be an existing bunch of conventional commercial buildings based upon the energy demand and generation profiles of MSR buildings. The equivalent commercial floor area that can be electrified by the surplus electricity of MSR BIPV is estimated. The MSR and commercial buildings are assumed to be equipped with high performance envelopes seeking net zero energy level. The space heating and domestic hot water demands of MSR buildings are served by natural gas, whereas for commercial buildings, these demands are fulfilled using grid electricity. The total roof area of MSR buildings is used for the installation of PV panels with the tilt angle of 45 degrees. The PV panel efficiency is assumed to be 18% and installation considering no self-shading of panels, whereas the occupancy and other loads are considered as per ASHRAE standards for the commercial buildings. Now this is the definition of problem. So we are using Energy Plus for the estimation of energy profile and as well as the generation profiles. The energy sharing potential is calculated in terms of the dependent area on MSR BIPV that is calculated using in-house MATLAB code. The program uses average monthly hourly energy profiles for both type of buildings. The series of objective function that is given in equation 1 is minimized using the MATLAB toolbox. The equation 1 defines the objective function, as I said previously. So the first term on right hand side is power generation by BIPV, second term is power consumption by MSR, whereas the last term PC is function of a commercial area, and PC is defined as electricity consumption by commercial building. That is function of commercial area. So this objective function is required to be minimized to 10 raised to -6. Coming to the results, so this figure shows the dependent office floor area on MSR building BIPV in various seasons: winter, spring, summer, and fall. So in winter, the maximum office area is can be relied on MSR BIPV at around 1 p.m. and accordingly for spring, summer, and fall, the peak energy sharing or the dependency of commercial area on MSR BIPV is possible at around 2 p.m. And similarly for the fall, the maximum dependency is also yielded at 2 p.m. Maximum dependent floor area fraction for office to MSR building is around 1.6, which is achievable in July. Similarly, we see the energy sharing potential between retail and multi-story residential buildings. The maximum energy sharing is enabled in winter at around 12 p.m. and accordingly for spring summer at 1 p.m. And similar to the previous comparison, the retail area of maximum around 1.6 times of the multi-story residential building can be relied on MSR BAPV. And coming to the supermarket, there is significant reduction in the dependency on the MSR BIPV because of the tremendous energy demand from a supermarket. So in this, the maximum area of 0.35 times of MSR area can be relied in July. So this is the maximum. So the previous maximum is around 1.6, whereas this maximum is around 0.35 for supermarket. So this is the summary of results. And coming to the conclusions quickly, for the combination of MSR office, the maximum possible dependent area is maximum and least are 1.59 and 0.64. And similarly for MSR and retail, the maximum sharing is possible in July and least in December. And the maximum sharing is possible in summer season, where the peak dependent retail to MSR floor area fractions vary between 1.42 to 1.63. Significant reduction in energy sharing potential for MSR supermarket combination. Overall, maximum energy sharing is possible in MSR and retail building. That is around 1.63 times of retail area that can be relied on MSR PAPV in July. So this research acknowledges the discovery grant received from ETSAC Canada. So these are the references. And at the end, we are welcoming you to ask any question related to this research at these email IDs, and thank you for your patience. Thank you very much.